The React Native perform well on multiple platforms and create a rich user experience. It's no wonder it's the choice of leading companies.
For your final project, you will create a beautiful functional mobile application for your portfolio, complete with interactivity to showcase during your job search.
You'll also be ready to collaborate with other developers as you will have learned to use Git and GitHub for version control.
If you're hoping to operate independently or in a smaller team, not to worry.
We've also got you covered when it comes to the basics of user experience.
You'll learn how to research a user's needs,
Create wireframes using popular industry tools like Figma,
And design interactivity.
In the final course, you will prepare for the coding interview.
You'll practice your interview skills, refine your resume,
And tackle some common coding challenges that typically form part of technical job interviews.
Who knows where you will end up?
Whatever the future of Connection looks like, you'll be part of its creation. Let's get started. Many people consider a career in software development, but are maybe not quite aware of exactly what goes on in different development environments. This course serves as an introduction to a particular environment known as mobile development, which encompasses the area of cross-platform development. This development area is best described as building software applications that can run on multiple mobile operating systems. Place that definition in a real-world context. Let's examine a typical mobile development project. As an example, let's assume our project is to create an app. Just to mention that when you come across the term app, it could refer to an app on your phone or to a web app that runs on a website or by some other online method. For ease of reference, here the sample project is portrayed as a phone app. It's our first project example, so let's pick an app that is not too complex. Perhaps a productivity tracker. And what does the productivity tracker aim to do? This app enables a business user to track items such as tasks, dates, times, and appointments. To help the user plan their schedule, it will include task lists with priority ratings, such as low, medium, and high. It will sync with other planning apps, such as calendars or project planners. Tasks can be upgraded to calendar slots so that they become items on the user's schedule. Various screen views are required, including weekly, monthly, and yearly overviews. Finally, there is the requirement to filter the tasks and appointments by several criteria, but especially criteria relating back to our task priority ratings. Filtering within specific time periods is also a necessity. And did I mention this app will be released to both iOS and Android phones? So if you are creating this app, you face some challenges. Let's list some of them. Don't worry if you don't fully understand all of the terms right now. After all, that's part of the reason you are taking this course. Some challenges in the productivity app project are cross-platform compatibility, user interface design, programming the code, which includes testing and debugging, and connecting to and synchronizing with third-party apps and tools. That is a short example of a not very complex app, but it does illustrate the sorts of tasks and challenges faced by cross-platform developers. During the course, you'll be introduced to these and the many other tasks that are the responsibilities of a mobile developer. You will start by learning how the web works. You will discover the fundamental components of the internet, such as networks, web servers, clients, and web hosting. You'll also explore web browsers, websites, and web pages. Next, you will learn about different platforms, how they differ, and how developers use cross-platform mobile development frameworks to create products that run on multiple platforms. Then you'll get the opportunity to gain the fundamental skills required to become a web developer using HTML and CSS, and discover the vast array of developer tools available to you. Finally, you'll explore React and React Native, their relationship to JavaScript, and how you can use them to facilitate cross-platform mobile development. Of course, you're not expected to build an app right away. There are many videos in your course that will gradually guide you toward that goal. Watch, pause, rewind, and re-watch the videos until you are confident in your skills. Then consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. You're not alone in considering a career as a mobile developer, and the course discussion prompts enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To be successful in the course, you must commit to a regular, disciplined approach to your learning regime. You need to be serious about your study, and if possible, map out a study schedule with dates and times that you can devote to attending the course. It's an online, self-paced course, but it does help to think of your study in terms of regular attendance at a learning institute. In summary, this course provides you with a complete introduction to mobile development and is part of a program of courses that lead you toward a career in software development. Technology continues to expand into a wide range of devices. As you go about your daily routine, you've possibly interacted with technology on many devices, from mobiles to wearables or even refrigerators. Partly because of the increase in these different devices, the demand for web and mobile developers is high and continues to grow. That growth makes cross-platform programming skills invaluable to any developer. Cross-platform developers make software applications that are compatible with multiple operating systems. And there's currently a shortage of specialized application developers. A specialized developer focuses on a particular domain with great in-depth knowledge. That type of demand means that upskilling yourself in a cross-platform application development could be a smart move. The skills you gain with a course like this can lead to many opportunities for employment. Both newcomers and seasoned developers can find job opportunities in the current market. In this video, you'll learn more about the roles associated with a skilled cross-platform application developer and the typical skills and tasks associated with such jobs. What kinds of things does a cross-platform developer do? Well, job descriptions can vary greatly depending on the position advertised. Each company and even each project may require a different approach. Some of the common tasks and responsibilities shared by cross-platform developers include writing code, always a prime requirement of a developer, and it's especially important to have clean, readable, and error-free code when the aim is to create apps compatible with several operating systems. Dealing with bugs, another time-consuming issue that typically occurs, involves finding and fixing bugs and attending to performance issues. Development of new app features and new UI or user interfaces for the app. Often this can entail upgrading existing code. And application monitoring to identify problems. You might do this by observing app performance or analyzing data. Developers are also involved in building clean and smooth animations and transitions. These are design techniques that help to provide an excellent UX or user experience. Other common cross-platform tasks include integrating third-party technologies like application program interfaces or APIs to connect the app with other technologies or code, writing tests, and releasing applications and updates to the Apple and Google stores. That's a brief overview of some common tasks and responsibilities you're likely to find in a cross-platform developer role. Many of those tasks involve coding. So what kinds of programming languages do cross-platform developers need? Well, the language required often depends on the project or the company, but language choice is primarily guided by the framework. A framework is a platform that provides the foundation and tools to develop software applications. It's sometimes compared to a template that you modify by adding your own code. The most important language for you to know is the one that the framework is based on. Just 3 are mentioned here, but many other frameworks are available. For instance, the React Native framework uses JavaScript. Flutter uses Google's programming language, Dart, and Xamarin is built using the C# programming language. Apart from the language associated with the framework, a development language may be related to particular platforms. For instance, Android developers use languages such as Java and Kotlin, while iOS developers use Objective-C and Swift. Then, many development tasks will involve using HTML, CSS, and JavaScript. These are used to build websites or applications. While not considered to be actual programming languages, learning these can expand your choice of job roles and projects. Okay, so I think I've covered that it's great if you know a language and its associated framework. For example, if you learn JavaScript, you're then ready to explore cross-platform development with React Native. And I've also emphasised that it's a bonus if you have proficiency in other languages. Furthermore, I'd consider it wise for cross platform developers to at least be aware of some related skills and concepts. That includes being knowledgeable about standard web development, the browser, and third party integrations like REST APIs, which help you to interact with RESTful web services, such as getting weather or geolocation data. Apart from the many coding skills, developers often work as part of a team, which can include other developers, project managers, QA professionals, and designers. Knowing how to use tools like Slack for chat, Zoom for video calls, and Jira for support tickets makes it easier for you to integrate and stay connected to the team. Your role may involve helping to plan projects and participating in the project progression by attending team meetings. In addition, you'll find that almost all developers spend some time researching their projects, watching emerging trends, and keeping up to date with the language and platform changes. Okay, let's say that you've mastered your cross-platform development skills. Now, where in the job market do you find work? Because cross-platform development skills are in demand, there are many roles available for web and mobile developers. Let's explore the job options. Cross-platform development is popular with small companies and startups who understand how apps can aid their growth, and is equally useful to large companies. For instance, they may want to build apps that help them gain a slight competitive advantage or foster engagement with their user base. Contracting development agencies often use cross-platform development as it helps them to quickly use existing talent and offer more services. There's a high demand for developers, but perhaps you are not attracted by any of the job offers. Well, having cross-platform development skills means that you can work as a freelance web app developer or start your own development company. From specialists to general software engineers, cross-platform development is used widely and is in very high demand. As a result, it's an invaluable skill set to have. You should now have a better understanding of a cross-platform developer's role, their responsibilities, and the skills they need.
About 84% of the world owns a smartphone, which means that whatever app you build is going to have tremendous impact. I'm Sarah Pack, and I am a software engineer at Meta based in Menlo Park, California. My story of being a mobile developer actually started with me as an economics major in my undergrad. While I was in my economics courses, I was hearing about all these hackathons, free pizzas, free swag. I decided to try one out, and it was the first time I ever picked up any mobile development. And I created a very almost embarrassingly simple app. I did not win, but I learned so much while creating this app, and I just loved the ability to see what I code come out to real life and see people use it. A typical day at Meta looks like me starting out with communications. So I look through a bunch of emails or chats, posts, whatever I might have missed. And while I do that, I pull the latest code and set up my development environment so that I can be prepared to code when that time comes. Typically, we have meetings scattered throughout the day, and that's to connect with cross functional partners like product manager, design, other engineers to push projects forward. When I'm not in meetings, then I get to focus on the technical pieces, like designing the technical architecture or, of course, coding. My favorite part of the workday is when I have a chunk of time to really dive deep into coding and, in particular, UI development, because I love just seeing what I code come out on the surface of a phone or some device and seeing the design and the buttons, the views, the images showing up. One of the most challenging things as a mobile developer is that you have to be aware of app size. And this means that any code that you build, any function that you add, needs to be as concise as possible. You have to be aware that the device has limited memory. And so, whatever you build and every line you add adds to that memory. And you have to be very careful and cautious about it. But the great thing is, this does help you to become a stronger engineer because you're really making sure that every line you add is going to work well and efficiently. Some technical skills that I use on a daily basis is first the technical language, as you might imagine. Currently, I use a mixture of native templates, blocks, and iOS native code to build our features. I would say another technical skill I use every day is data analyses because these are important for understanding how a feature works, whether people are finding a benefit out of it or not, based on whether they're using the feature or not. And this really helps to inform the engineers what to fix and what to improve. Communication, that one is key because we at Meta really work as a team and we have a lot of different functions. So, coming in from an engineer background where we might speak with a lot of technical lingo, we have to make sure that we use layman terms to convey why building a certain thing may take so much time or why it's fast to build another way, and be able to convey that in a very concise and understandable way for product managers or designers or content designers who don't have any technical background. And this really helps to drive the projects forward. There is no shortage of things to build at Meta. So, being able to prioritize what will be the best experience for users and also be efficient in terms of building for the engineering technical side is really important to balance out and prioritize so that we really hone in on the best features. The way we work with iOS and Android developers is a lot of collaboration. Within each platform, all the engineers work together, divvy up tasks to build for that particular platform. But across the two platforms, we also collaborate a lot because the way we implement on one, such as Android, we implement very similarly on the other, such as iOS. So we share a lot of our implementations across the board. And because both also share the server work, we are able to collaborate a lot and share our knowledge. The way that a mobile developer's role is different from a UX or UI designer is that the UX or UI designer creates the mocks and the draft form of what we should build on a screen, what it should look like. It's like a drawing. And then the engineer then takes that and actually builds it and makes it work on an actual device. So you can kind of think of an analogy of like an architect who would draft out the drawings of the building, and then a constructor then goes in and actually builds it. And so the engineer is the constructor, and the UX UI designer is the architect. I have noticed that good engineers are able to build out the UI fine, but excellent engineers really understand what's going on under the hood so that they can efficiently debug an issue. And if you have that solid foundation, you'll be a very strong mobile developer because you'll understand what's happening. Technology does move fast, and with mobile development, you really do interface with people. People's behavior affects what we build. But we've also found that technology influences people's behavior. It's really interesting to be at the forefront of seeing the evolution of how these two influence each other and hopefully and ideally ensuring that technology does its best to serve people. Being a mobile developer is a very specialized skill set, and it is high in demand in the market. Here at Meta, we are always in need of more mobile engineers. So it'll be a great skill set to have. It'll really truly make you a well rounded engineer compared to other engineering tracks because you're not only building algorithms or code, but you're also trying to interface with the user, which means you have to understand the product and you also have to understand the data. It is really special to be able to know that what I build impacts so many people and that billions of people use it. That's what gets me up every day at work because I know that the work I put in really helps people to have a better experience within whatever technology they're using within Meta. And I wish you the very best on your exciting journey to become a mobile developer.
Hello and welcome. Did you ever find yourself searching for something online? How long did it take to get a response from your search? You search for something and you get a response back in no time. That's really something, isn't it? But did you ever think about how it all happens? In this video, I will guide you through the basics of how the internet works. Let's start at the beginning. You open your favorite app on your device and you're instantly connected to the world. This is all made possible because two devices connect and communicate via a wired or wireless connection, forming something called a network. You can connect multiple devices to this network, but this becomes very complicated very quickly as each device needs to connect to every other device to communicate effectively. This problem is solved by something called a network switch that connects multiple devices and allows them to communicate with each other. The network switch can connect to other network switches, and now two networks can connect. These network switches then connect to more network switches until you have something called an interconnected network. This interconnected network has another name that you might be familiar with. It's called the Internet. When we use websites or video streaming services on the Internet, these are provided by computers called servers. Our devices are called clients. This is known as the client-server model. The Internet connects the entire world. Have you ever had a video call with someone on another continent? That video data travelled through large undersea cables connecting the world's networks, and these cables can transfer huge volumes of data per second. There are a lot more technical details that go into making the Internet possible, but this is the main idea. Hopefully, this gave you the big picture of how the Internet works. You may have heard the terms web pages and websites, but what's the difference? A web page is a document that displays images, text, videos, and other content in the web browser. A website is a collection of web pages that link together. You've likely visited many websites this week. In fact, you're watching a video on one right now. Let's explore an example where you visit your favourite encyclopedia website. When you arrive at the homepage, it contains many links to different articles. Clicking on one of those links brings you to a new web page article, and that article links to even more articles on other web pages. If all these web pages have a similar address in the web browser's address bar, it can be safe to assume that they belong to the same website. However, the links on the page do not all have to link to the same website. They can also link to other websites. For example, when you visit your favourite search engine and search for a phrase, the search results are a list of links to other websites. Did you know that as I'm talking to you, thousands of websites are being launched to the Internet? Every day, hundreds of thousands of websites are launched. To put things into perspective, the Great Pyramid of Giza has 2.3 million blocks of stone. So think about it. In 1 week, there are as many new web pages as stones in the Great Pyramid. With current internet speeds, it would take 3 million years to download all the web pages on the Internet. And all of these billions of varied web pages rely on the same core technologies. Most people interact with websites in some form daily, but few know how a web page actually works. I mean, what's it made up of? And just how does that web page get from the web server to what you see on your screen or device? Well, let's explore that now. In its most basic form, a web page is just a text document. You can open and edit with any text editor, but developers usually use more sophisticated tools for working with web pages. If you want to work with a web page, you need to know about 3 technologies and understand how they interact. They are HTML, CSS, and JavaScript. HTML structures the content you see. CSS controls the colors and style, and JavaScript is responsible for the user interaction. As a web developer, you will work with these technologies every day and understand how they work together. I always like to imagine it like this. Think of a shop. HTML is the actual building, the structure. CSS is the interior decoration and landscaping outside, and JavaScript is just like the business, the services offered, and the people coming in and out. Let me give you a brief overview of each of these technologies now. HTML stands for Hypertext Markup Language. It works by using something called markup tags. These tags describe the content that is displayed in the browser window. This content can be things like headings, paragraphs, images, and even multimedia elements such as audio and video. The way HTML describes the content is known as markup. CSS is short for cascading style sheets and adds visual enhancements like colors and layout to the web page. This is commonly known as styling. It works by enhancing the HTML elements and telling them how to display. Have you ever noticed a friend change their color or style of their hair? Well, your friend's hair is like the HTML, and the color and style is CSS. The last technology is JavaScript, which is a programming language built into the browser. JavaScript provides web developers with tools for interactivity, data processing, control, and action. Have you ever tried to log into a website only to be told that the information you provided was incorrect? Or browsed your favorite video streaming site and seen content update in real time? Well, that's JavaScript in action. JavaScript is the powerhouse of a web page. It has the ability to manipulate the content that you see on the screen as you interact with it. In fact, without JavaScript, websites would be kind of boring and very limited in terms of what you can do. Okay, you now know about the essential technologies a web page contains, but how exactly does this code get translated to display the content that you see on your screen? When a copy of that web page is sent from the web server to your browser, each line of code is processed in sequential order from first to last. As each line is interpreted, the browser creates the building blocks, which is the visual representation you see on the screen. This creation process is known as page rendering. The response from the web server must be a complete web page in order to fulfill the request to show the page in the browser. You will learn more about page rendering from the additional reading at the end of this lesson. And there you have it. You now have joined the exclusive group of developers who know how a web page works. You learned about the technologies that make up a web page and how they interact with each other. You also learned that the page is rendered by the web browser to display what the end user sees on the screen. In the time since you started watching this video, another few thousand websites launched. Every one of them is another example of modern web developers building and adding to the ever-growing internet. Are you ready to become one of them? A server is a computer that runs applications and services, ranging from websites to instant messaging. It's called a server because it provides a service to another computer and its user, also known as the client. It's typically stored in something called a data center with hundreds or thousands of other servers, all running different services connected to the internet. There are many different systems in data centers to ensure that servers have continuous power, continuous internet connection, and are kept cool 24 hours per day. Did you know that there are data centers located all around the world? Many websites use these to allow you to access your content quickly from the data center nearest to you. The data center servers are built based on the server's purpose. For example, if the server is only to be used for storing images, it might have a lot of hard drive space, whereas a server computing complex calculations might need a fast processor and a lot of memory. This is usually referred to as the server hardware, the physical components of a server. Once the server hardware is installed in the data center, a piece of code can now run. The code that runs on the hardware is commonly known as software. One way I like to remember this is to think of hardware as something you can physically touch and is difficult to change, as you need to physically replace components. Software is soft or easy to change, you just replace the code running on the server. The services a server can run can vary, but in this video, you will learn about a type of server software known as a web server. A web server has many functions, which includes website storage and administration, data storage, security, and managing email. Another primary function is to handle something known as a web request. When you open a browser on your device and type the name of the website, it's the job of the web server to send you back to that website's content. This process is known as the request-response cycle, and you will learn more about it later. Web servers are also designed to respond to thousands of requests from clients per second. In this video, you learned about web servers and how they consist of hardware and software. You also learned that one of the primary roles of a web server is to respond to web requests from the client. You use a web browser every day on your devices, and you probably have one open right now watching this video. But do you really know how they work? In this video, you will learn what a web browser is and how it receives and displays content. Let's get started. A web browser, or browser for short, is a software application that you use to browse the World Wide Web. It works by sending a request to a web server and then receives a response containing the content that is to be displayed on the screen of your device. Once the browser is open on your device, there is the address bar where you input the address of the website that you want to visit. The address is commonly known as the Uniform Resource Locator, or URL for short. The URL contains the protocol, or the HTTP, the domain name, usually the name of the website, and the file path, or the path to the page that is displayed. When you make a request using this URL, the browser and server communicate using a protocol known as the Hypertext Transfer Protocol, or HTTP. Once the web browser receives the content, it displays it on the screen of your device. This exchange of information is made possible by something known as the request-response cycle. Now, let me demonstrate this using an example many of us are familiar with, searching the web. First, you open a web browser, which is a software application. Next, you type the name of your favorite search engine. The name you type contains something called a domain name. Then, when you press enter, the web browser sends a request across a network and connects to another computer on the internet called a web server. The web server is a special type of computer that allows other computers to make requests for data. The web server responds by sending a web page back to the browser. Once the browser receives all the response information, the search engine web page is made visible. The web page is a coded document that is rendered by the browser and then presented visually to you, the end user. Now that the search engine web page is loaded in the browser, you interact with that page to search for what you want to find. For example, type restaurants near me in the search bar and press the search button. Once again, the browser prepares and sends a request to the same search engine web server. This time, the request contains the added instructions to search for the phrase restaurants near me. The search engine web server processes the request by taking the keyword and using it to find the requested data. This data is stored in something called a database, which is connected to the web server. The web server then picks up that data and sends it back to the browser. When the web browser receives the full response from the web server, it again renders a visible web page with links to some restaurants, a map showing nearby locations, and more related information such as reviews, lists, and even reservations. Success, and all made possible by computers having a conversation. You have now gained an insight into how the request-response cycle works. And this web request cycle is very similar for a number of other activities we do online, be it chatting with friends, watching our favourite movie, or sharing files with our work colleagues. That is just a brief summary of how the internet works. The next time you search for something online, think of all the steps and data that gets exchanged to complete your request.
How much time do you think you spend each day using mobile apps? Studies show that people spend on average a fourth of their lives using apps. Mobile apps have become an important part of people's lives. Tasks such as booking accommodation, ordering food, or staying connected are now easier than ever. In this video, you explore how the mobile industry evolved to become an integral part of modern life. It all started when the first handheld cellular phone was invented in 1973 by Martin Cooper. Another major event in the 1970s was the development of cellular networks that connected mobile phones to the internet. The public, however, only got access to mobile phones in the 80s. But in the 90s, when the first smartphone went public, it turned the world on its head. The IBM Simon was built by IBM and was one of the first instances of a handheld touchscreen device. Released in 1994, the IBM Simon went on to sell around 50,000 units in total. Although this did not create immediate change in the industry, people began to see the value of apps dedicated to tasks like instant messaging, and the rate of mobile development increased greatly. The early 2000s brought two important dimensions to the evolution of mobile apps. The consumer demand for a computer-like experience on a mobile device drove the development of the technology. One particular area that accelerated rapidly was touchscreen technology. All of this meant that operating systems had to provide more and more sophisticated platforms for apps to run on, and app stores were created to give users access to thousands of apps. The game-changing operating system Android made its appearance in 2003 and competed with the two giants of the time, Symbian and BlackBerry. And 2005 was a big year in the mobile world. It was the year when Google bought Android for about $50 million. In the meantime, smart devices became more advanced year after year and could run more sophisticated operating systems. The long-awaited iPhone was launched in 2007. This event marked an important growth in the Apple fan base. A year later, in 2008, the first Android operating system was released to the public. Android is the leading operating system used today. Now, let's cover a brief history of the main app stores. In 2008, Apple's App Store went online with over 500 apps. And in 2009, Samsung announced their App Store for mobile devices manufactured by Samsung Electronics. In 2010, Apple released their iPad with over 3,000 apps on their store. 2012 was another defining moment for app stores when Google rebranded their App Store as Google Play. And then in 2015, Google revolutionized its App Store. They introduced a system that allowed them to review apps before they are published on Google Play. Today, the mobile operating system market is largely dominated by two major tech companies, Google and Apple. Millions of developers around the world are building apps that run on their operating systems, Android and iOS. That was a brief history of the evolution of cell phones and mobile app stores. Have you ever scrolled through an app store and imagined how cool it would be to develop your own app? Fortunately, there are many tools and resources available to help you create iOS apps. Let's discover how to do that. By the end of this video, you'll be able to explain iOS, one of the most popular operating systems in the world, identify the top integrated development environments or IDEs for iOS development, and you'll explore an example IDE to understand how they work. As a mobile developer, it's important to make sure that your app meets the requirements of the operating system it will run on. Otherwise, users may have a frustrating experience. As one of the most popular operating systems in the world, compatibility with iOS is a great standard to aim for. iOS is an acronym that stands for iPhone Operating System. iOS is based on an older Apple operating system called Darwin, which itself is based on Unix. All Apple's mobile devices run iOS. A prominent feature introduced on iOS devices is touch gesturing, which allows users to perform actions through such movements as swiping, pulling, and tapping. Apple devices also make use of accelerometers and gyroscopes, enabling users to switch between the orientation of applications. They can also react to the tilting of a device. This means that your app can detect if the user's device is placed vertically or horizontally and adjust itself to give the best view. This type of functionality has helped to greatly increase the iOS user base over the years. With this rise in popularity, Apple has given mobile developers more control and access to the features of iOS. So let's examine the history of the iPhone. iPhone version 1 was launched in 2007. From iPhone OS 2.0, developers had access to an SDK, or software development kit. An SDK is like a box filled with tools that mobile developers use to build apps for iOS. Version 3 brought huge improvements, such as call location for identifying where a device is, and push notifications to allow easy updates. iOS 4 was the first version to allow multitasking. And what about right now? The answer is that more improvements are continually being added. Now that you know a bit of the history, let's learn about the best integrated development environments, or IDEs, for iOS development. The first is Xcode, which can help you code faster by completing code lines automatically. It also has complete syntax highlighting for Swift, which is a language you'll learn about soon. Next, there is AppCode. This IDE from a company called JetBrains has a development environment that ensures fast and accurate execution of code. Another solid choice is Atom, which was designed and developed by GitHub. Atom is notable for its customizable environment and easy to install add-on packages. You should also consider Sublime Text. While this is a code editor rather than a full IDE, it is functional, clean, and fast, and features helpful built-in tools. Finally in the list is CodeRunner. This is an easy-to-use programming editor for Mac OS. It is quite a flexible IDE that supports a wide range of languages. Note that some of these IDEs are free, while others are designed for commercial use and require the purchase of a license. This should be considered when making the choice that best suits your needs. So now you know about some great options for IDEs, but how about programming languages? Which one is best suited for iOS development? While many are supported, let's focus on one of the most efficient languages for iOS development, which is Swift. Swift is a language created by Apple. It gives developers a single platform to create apps for the wide range of Apple devices. Xcode has supported Swift since the release of version 6 in 2014, making the two a popular combination for app development. Also note that the Windows operating system does not support Xcode. So, with the support of Xcode, mobile developers can use Swift language to develop engaging apps for Apple devices. Devices such as the iPhone, MacBook, and Apple Watch. Okay, let's demonstrate an iOS development IDE. I'll explore the Xcode IDE as it appears on the Apple MacBook. As you have learned earlier in this lesson, Xcode was developed by Apple to create software or apps for various operating systems, such as macOS, iOS, watchOS, and tvOS. It is also the only Apple-supported tool that can be used to create and publish apps to the Apple Store. In my layout, the coding window is found in the center of the screen, while the left window displays the folder structure and the individual files. This interface is beginner-friendly, but also allows for more experienced developers to work quickly and effectively. Xcode supports a wide variety of programming languages, including C++, Objective-C, Objective-C++, Java, AppleScript, Python, Ruby, and Swift. As Swift is the most commonly used language in Xcode, my example codebase is written with that language. It's great to know that it's a straightforward process to publish your app on the Apple Store. By using this IDE, you'll be able to develop, test, and deploy your app easily in an intuitive and seamless way. To recap, in this video, you have covered what is iOS and what are its requirements, what are the top IDEs that are used for iOS development, and lastly, what does the Xcode IDE look like in action? That was an introduction to the iOS platform, its IDEs, and associated languages. I'm sure you can't wait to learn more about building apps. There were once multiple competitors in the field of mobile operating systems, but currently just two dominate the market: Google's Android and Apple's iOS. While iOS has many dedicated users, it's actually Android that has the largest installed base of any mobile platform, with over 2 million new Android devices activated every day. By the end of this video, you'll be more familiar with what Android is, and will get to know some of the common tools and languages used to develop apps for it. So, what exactly is Android? Well, it's a mobile operating system that was first launched in 2008 and is the base system of many phones and tablets worldwide. Android is the largest installed base of any mobile platform. As a result, there is a large demand for apps to be developed for the platform. Apps are most frequently developed in an integrated development environment, or IDE, which is software that helps you build applications. It includes tools to write code and debug code, and may come with many other developer tools. There are a few IDEs available for creating Android apps. Here's a few important ones. Android Studio, which is great for building your app in a more productive way at scale. NetBeans IDE, which allows for development with Java. Visual Studio Code, also known as VS Code, which is a source code editor from Microsoft for Windows, Linux, and Mac OS. Finally, there is AIDE, which enables developers to create Java or XML-based Android apps using the Android SDK. In addition to choosing an IDE, you'll also need to decide on a development language, and Kotlin is a good place to start. Kotlin is a cross-platform language, which means it will work on multiple computing platforms. It was designed to replace Java for Android app development. Additionally, there are certain features that make Kotlin the best fit for Android developers. This includes compatibility, in that Kotlin-developed apps can run on older devices, interoperability, meaning that Kotlin and Java can both be used in the same project, shorter code compilation time, which allows faster work when adding code and testing code in small increments, and the language has the reputation of being easy to learn, especially for developers who are already familiar with other modern programming languages. Now that you know more about Android app development, let's explore an IDE to get a better idea of what you'll be working with in your future development role. This is Android Studio, a powerful and sophisticated IDE designed to develop, test, and deploy applications to the Play Store. It's the only officially supported IDE for Android development. It's an easy IDE for beginners to use, but it's also powerful enough for more experienced developers. Android Studio is comprised of a software development kit, or SDK, a collection of tools and other components. Android Studio supports two major programming languages, Java and Kotlin. In this demonstration, the focus will be on Kotlin. In the upper left part of the screen is the project panel, which shows how your project is structured and organized and provides quick access to project files. The software has a clear interface. Its features help you code and test more effectively. Features such as an intelligent code editor that analyzes for errors and a built-in emulator to simulate how your app would run on a real device. Perhaps one of the most useful features is the Java to Kotlin converter tool. This allows you to use a mix of Java and Kotlin code in a project, useful if you're moving from one language to the other. In this video, you learned about the popularity of the Android platform, the most commonly used IDEs for Android development, and the rise of the Kotlin programming language. Have you interacted with a web page on your computer or device today? If the answer is yes, then you have interacted with JavaScript code. You can think of JavaScript as a language of the web. In this video, you will learn how it works and how it is used to power your web and mobile applications. In the early days of the web pages were static, meaning they didn't have any interactions. Technologists envisioned that interactions and animations would be part of its future development. The American entrepreneur and founder of Netscape Communications, Mark Lowell Anderson, believed that web pages could be manipulated by using a scripting language, making web content interactive and dynamic for users. So the idea to build a language such as JavaScript was born. In the beginning, developers mainly used JavaScript to add interactivity to websites. For example, adding an item to your shopping cart on an e-commerce website. In recent years, JavaScript's popularity has grown, and it has become one of the most used languages worldwide. Technological advancements allow developers to now use JavaScript for a wide range of applications, such as web and mobile development, streaming services, and even games. Okay, so now you know what JavaScript is. Let's explore one of the main places you will find JavaScript. That's in the web browser. Typically, in programming, once you write some code, that code needs to be run or compiled into something called machine code to be understood by the computer. Browsers have a specific software component called a JavaScript engine that executes the JavaScript code and sends it back to the browser for rendering. So when a web page loads, the JavaScript browser engine does all compiling in the background. Then the web page is loaded successfully and users can interact with it. The JavaScript engine can also be referred to as the ECMA script engine. And typically, the companies that make web browsers have their own built-in JavaScript engine. For example, the JavaScript engine for Google Chrome is called V8. Mozilla Firefox uses SpiderMonkey, and Apple Safari uses JavaScript Core. Let's explore each of these now in a little more detail, starting with V8. V8 is Google's open source high-speed JavaScript engine. It is written in the C++ programming language and used in the Chrome web browser. This engine works with the most popular operating systems such as Windows, macOS, and Linux. Next is SpiderMonkey, which is the JavaScript engine of the Mozilla Firefox web browser. It's also developed in C++ and used to power Mozilla Firefox and other products. Finally, JavaScript Core is an open source web browser engine that allows developers to build a browser using its code. This engine powers apps such as the Safari browser used on macOS. Okay, now that you've learned about JavaScript and the JavaScript engine, let's now explore one of the reasons why JavaScript is so popular, and that's speed. Modern browsers can run JavaScript code much faster thanks to something called just-in-time compilation. This feature takes advantage of both compilation and interpretation of the JavaScript code. In this video, you learned about JavaScript and how it's the language of the web and is used to build web and mobile applications. Millions of websites are powered by JavaScript. As an aspiring developer looking to work with the web, JavaScript skills are essential. Are you ready to take the next steps and learn more about this exciting language? The internet is one of the most transformative and fast-growing technologies of modern times. Across the globe, billions of people visit websites from their web or mobile browsers every day. But have you ever stopped to think about the software that allows you to navigate sites from around the globe? That's right, I'm talking about the web browser. In this video, you will learn how web browsers give you access to content on the web. You'll also learn about the role that JavaScript plays in that and the differences between web browsers and mobile browsers. The internet has provided the means to access information and resources in the shortest possible time. By using a browser on a smartphone or computer, you can access websites from any part of the world in seconds. So, what makes this all possible? Let's explore and find out. You can think of a browser as an application designed to download a web page and present it in a way that is clear and understandable to a visitor. In order to access a website, two major things need to happen. First, the user enters the address in the browser's address bar. Then, the browser downloads the page and presents it in text, images, video, audio, and interactive elements. There are many browsers available, however, the market is dominated by just three: Google Chrome, Apple Safari, and Mozilla Firefox. Many websites allow users to interact with content, and JavaScript is just one of the technologies that make it possible. JavaScript allows you to alter just about every section of a page. This includes the content, the look and feel, and of course the response to user action. So now you know that JavaScript plays a crucial role in offering users a good browsing experience. But what does JavaScript actually do to make this all happen? Well, when a browser downloads a web page, it is received as code, specifically HTML, CSS, and JavaScript. But this code needs to be turned into a page that users expect to see. This is where the browser comes in and uses a JavaScript browser engine to do the job. Depending on the browser, JavaScript engines can have different names and may not work in exactly the same way. Now that you've covered how browsers work, let's explore the major differences between mobile and desktop browsers. Some of the key advantages of mobile browsers are that they allow quicker web page access, they enable seamless multitasking, they are also very portable, they are usually updated regularly to improve the user experience, and they consume less data bandwidth. Some major benefits of desktop browsers are that they are generally more stable, they allow a larger view of a web page, they allow full access to website content, and make it easier to navigate between pages. In this video, you learned how browsers download and present the web content that you access every day. You also covered how JavaScript improves your experience and the key differences between mobile and desktop browsers. I'm sure you, like most people, expect a great user experience when you use the web. But have you ever wondered how the size of a website can so easily adjust between different devices, like laptops and mobile phones? Well, the answer is responsive design. Responsive design means that a web page can automatically stretch or shrink depending on the screen it's displayed on. In the past, developers had to create two versions of a website, one for desktop and one for mobile devices. This was expensive and time-consuming, so responsive design was developed to solve these issues. As a developer, you will probably work with responsive design every day. Let's explore how it works. After watching this video, you'll be able to explain how responsive design is used to provide the best user experience based on the device that the website is viewed on. Describe CSS media queries and screen resolutions. Classify fluid images and differentiate between fixed and fluid grids. Phone, tablet, and computer screens, including the one you're probably using right now, are made up of thousands of tiny lights called pixels. The resolution of your screen refers to the number of pixels it contains, most often expressed as a number of horizontal pixels multiplied by the number of vertical pixels. For example, a common computer screen resolution is 1920 pixels in width and 1080 pixels in height. Thanks to responsive design, media queries can determine the resolution of a screen and instruct a website to use the best layout. However, today we have many different screens with different resolutions, which is why responsive design is so important. And it is complicated by new high-resolution screens like the one found in your mobile phone. Responsive design is a set of 3 techniques that allow a website to automatically change its visuals. In other words, to respond based on the device it's displayed on. Responsiveness is created by a combination of the 3 techniques: flexible grids, fluid images, and media queries. First, instead of defining website element sizes based on pixels, Flexible grids are defined in percentage values, allowing them to adjust depending on screen size. This will determine the percentage of space each element will take on the screen. Second, when set correctly, fluid images allow images to scale down to a smaller size, but not grow larger than its original size and become lower quality, what is known as pixelated. The scaling depends on the screen or window size of the display device. Finally, media queries allow developers to query the display size, orientation, and aspect ratio of the device to help the website display properly. When used together, flexible grids, fluid images, and media queries allow you to build a website that will automatically adjust its layout based on the device, thus delivering a responsive grid. In responsive design, the pixel value specified is often referred to as the breakpoint. A breakpoint is the point at which a website's content and layout will adapt to provide the best possible user experience. Remember that responsive design also applies to presenting the best user experience across platforms. With that goal in mind, developers use cross-platform mobile development frameworks to create products that run on multiple platforms like iOS, Android, and Windows. These frameworks include products like React Native, Angular, Flutter, and Appcelerator. In this video, you covered responsive design and how it helps developers build products that offer the best user experience across multiple devices. You've reached the end of this module on mobile applications. Over the course of this module, you've explored web and mobile or cross-platform developer roles, the basics of how the web works, and familiarised yourself with key concepts in mobile development. Let's take a few moments to recap the key lessons and skills that you gained along the way. You started the module with an overview of cross-platform developer roles, and you can now outline the role of a cross-platform developer by listing some of their common day-to-day tasks. These include design, planning, research, building, and maintenance. You can also identify several of the businesses and areas in which cross-platform developers share their skills, like startups, agencies, and Meta. And you're able to explain the languages and skills that cross-platform developers require to succeed, like JavaScript and user interface, or UI development. Next, you moved on to explore the basics of how the web works. In this lesson, you familiarised yourself with the technologies that power the internet. Having completed this lesson, you can now identify what a network is and demonstrate an understanding of how the internet works, identify the client-server model, and explain the request-response lifecycle. You also explored the basics of key concepts like web pages, web servers, and web browsers. In terms of web pages, you can now differentiate between a website and a web page by outlining the key elements of each, outline the purpose of HTML and CSS, and provide an explanation of how they work, and identify the benefits that JavaScript provides to a web page, like interactivity and data processing. You're now familiar with the basics of web servers and can explain how a data center provides storage and power for web servers, differentiate between the key functions of web server hardware and software, and outline how a web server handles requests through HTTP or Hypertext Transfer Protocol. And you also investigated the third key technology of the web, which is web browsers. Following this investigation, you can now explain what a web browser is, describe how a web browser receives content from a web server and displays it for users, and outline the request-response cycle. This includes identifying how languages like HTML, CSS, and JavaScript generate and interact with web pages. The final lesson that you undertook in this module was an introduction to mobile development. During this lesson, you explored key concepts around mobile applications, like development platforms, languages, and interactivity. Having completed this lesson, you can now explain the importance of mobile technology to everyday life, outline the development of mobile technology over the last few decades, and identify major mobile operating systems like Android and iOS. As part of your journey to become a mobile developer, you also explored mobile operating systems like iOS and Android. As a result, you learned how to explain what iOS is alongside its benefits, identify the leading integrated software environments or IDEs for iOS applications such as Xcode, and outline the purpose and function of the Swift programming language. Explain what Android is, outline the leading integrated software environments, or IDEs, for Android applications, and identify the benefits of the Kotlin language in Android Studio. You investigated JavaScript and learned how to explain the purpose of JavaScript and provide a brief overview of its history, outline how JavaScript interacts with the browser in order to generate interactivity, and identify some of the unique JavaScript engines utilized by major browsers. You studied mobile and web browsers and can now describe how a browser downloads and renders a website, outline how JavaScript enables interactivity in a web browser, and identify the advantages of mobile and desktop browsers. And finally, you explored responsive design and learned how to explain the concept of responsive web design, describe how responsive web design works, and outline the advantages of responsive web design. You're now familiar with mobile applications, including common web and mobile developer roles, how the web works, and the basics of mobile development. That's a great start to your React Native journey. Well done.